This will be for the con assignment remainder theorem. Okay, so they graph the polynomial here, and they want to know the remainder when the polynomial p of x is divided by x plus 1. Okay, so when we are dividing by x plus 1, you want to change the sign on that and make it -1. Okay, -1. So in order to find the remainder when p of x is divided by x plus 1, we want to plug in -1 in place of x in the polynomial. Okay, but we don't have an equation, we have a graph. So let's go to x equals -1. This is the x-axis, and here is x equals -1. Okay, so at x equals -1, the graph is right here, and the y-coordinate is just 3. So that's it. You put 3 in the box. Okay, so we have our polynomial here where k is an unknown integer. P of x divided by x minus 1 has a remainder of 0. What is the value of k? Okay, since we're dividing p of x by x minus 1, you want to plug in +1 in place of x. All right, so we're putting in +1 in place of x. And the remainder equals 0. So we plug in +1, and the whole thing should equal 0 when we plug in +1. So let's do that. All right, instead of p of x, I'm going to write p of 1, since we're plugging in x equals 1. So it's going to be 1 to the 4th minus 2 times 1 to the 3rd plus k times 1 minus 4. And since the remainder is 0, we set this equal to 0. Okay, 1 to the 4th is 1. 1 to the 3rd is also 1 times -2. K times 1 is just k. Minus 4 equals 0. 1 minus 2 is -1. Minus 4 is -5 plus k equals 0. Okay, we can see k is going to be 5, right? Because if you add 5 to both sides, cancels. So just enter that in the box. K equals 5. Okay, what is the remainder when p of x is divided by x minus 2? Okay, always change the sign of the thing you're dividing by. So if we divide by x minus 2, that -2 becomes a +2. Okay, so we're going to plug in x equals +2 in this equation here. All right. So instead of p of x, it's going to be p of 2. And wherever there's an x, you plug in 2. 2 times 2 to the 4th minus 2 to the 3rd plus 2 times 2 squared minus 6. All right, you can use the calculator if you want. This is going to be 16 times 2 minus 8. And this is 2 times 4 plus 8 minus 6. -8, +8, cancel. 32 minus 6 is 26. I hope I did that right. Okay, but they're looking for the remainder. So when you plug in 2, you get the remainder. when dividing by x minus 2. Alright, so whenever you plug in, make sure you change the sign of the thing you're dividing by. Okay, we have our polynomial where k is an unknown integer. And when we divide it by x plus 1, we get a remainder of 2. Okay, again, since we're dividing by x plus 1, we want to plug in negative 1. Okay, always change the sign. So we're plugging in x equals negative 1, and we're going to get an answer of 2. Alright, so let's take this right here, and it's going to be p of negative 1. Okay, and wherever you see an x, plug in negative 1. 2 times negative 1 to the 4th minus negative 1 to the 3rd. Make sure you watch your parentheses. Okay, it's minus negative 1 to the 3rd plus 2 times negative 1 squared minus k, and that whole thing is going to equal 2 because the remainder is 2. Alright, again, you can use the calculator if you want. Negative 1 to the 4th is just 1 times 2. Negative 1 to the 3rd is negative 1, and this negative makes it positive 1. Negative 1 squared is 1 times 2 minus k equals 2. Alright, from here it's easy. 2 plus 2 is 4, plus 1 is 5. Okay, and you can do this in your head. Obviously, k is 3 because 5 minus 3 equals 2. Alright, one more with the graph. The polynomial is graphed. What's the remainder when the polynomial is divided by x plus 2? Okay, when you're dividing by x plus 2, you're plugging in x equals negative 2. Always change the sign. Okay, now we don't have an equation to plug in, but if we just go to x equals negative 2, this is the x-axis. X equals negative 2, go to the graph. That's right here. Okay, what's the y coordinate? When x equals negative 2, y is negative 4. So you would get negative 4 when you plug in negative 2.